into the next topic here when we talk about recursive versus explicit formulas. When I asked you guys to find the next term in this sequence, 27, 34, 41, and 48, you guys told me to find the next term. What do? We add 7, okay? That is basically what we call a recursive formula. I want you guys to write this down on the slide right now. In a recursive formula, each term is found by doing something to the term before it. That's all a recursive formula is. Okay? I'm telling you what's right. So, in a recursive formula, every term is dependent on the term before it. You can't find the 10th term until you found the 9th term. But in order to find the 9th term, you need to know the 8th term. So you actually have to list this entire thing. Not a lot of fun.
Oh, no. I only got into recursive formula.
So when you think about recursive formula, again, it's going to be every term is dependent on the term before it. And what I want you guys to do is we're going to look at this setup right here. Actually, no, that's the wrong one. Also, use the right pen. Try this one. Oh, come on. Really? Come on.
Just using magic.
This one should be doing it.
Maybe it's not so magical.
There we go.
It's because I snapped my fingers.
Alright, guys, what I want you to focus on right here is when we look at a recursive formula, there's some terms I want you guys to realize. This A sub n, that's how we say that, A sub n, sub meaning subscript. Okay, so it's called A sub n. What that means is the nth term, hey, focus. So guys, when we look at A sub n, now, what's this notation here? How would we say that?
A sub
n minus 1. Okay. So, here's my question for you. If I'm looking at the 10th term, how would I rate that?
A sub n is 10.
No. How would I represent the 10th term? A sub 10. Okay. What's the previous term to A sub 10? A sub 9. Okay. So, in this sequence, the previous term is just one less than the actual term itself, right? So anytime you guys see this A sub n minus 1, you need to think of that as, how would you actually interpret that? The previous term. And you need to recognize that A sub n minus 1 is the previous term. So I want everyone right now, you're going to circle, highlight, whatever, and I want you to write above that previous term. That's what the A sub n minus 1 represents. It's the previous term. So notice we're doing something to the previous term. What are we doing? We're adding 2. Okay, so the next term is 2 more than the previous term. Now the problem with the recursive formula is we have to have a starting value. So anytime you're given the recursive formula, you're always going to be given the original term, the first term. So you're going to be told the first term. That's what the A sub 1 means. It's your first term. So that's our starting point. So what do we ask to do with this problem? What do we ask to find?
Find A sub 5.
Which means what? Which term? The fifth term. Okay. So it's actually not that bad. It looks complex, but it's really not. We start off, in order to find A sub 5, what do I need to know?
A sub 4.
If I want to know A sub 4, I need to know.
A sub 3 and A sub 2.
Okay, so you see the problem here. So we start off with A sub 1 is 2. How do I go to A sub 2? You got to add 2 to it, right? So therefore, 4.
6.
What is A sub 3? 6. What is a sub 4? 8. And what is a sub 5?
Dang,
And now we finally got to our point. Now, obviously, these might be a little more complex than this. But you guys kind of get the idea, right? In order to find the fifth term, you have to find the term before it, and you keep working your way up from the original term. Now, as we already stated, what if I asked you to find the 100th term?
Oh,
you
boy.
have to do it 100
Yeah.
times. Did you just multiply it by 2?
Yeah.
No.
Oh, hold on. What?
You gotta multiply by 2 because think of this, a sub 1, 2,
Uh-huh.
and then times the sub by the number, whatever that equals.
Oh, so if I take my term number, which right, that is basically n, and you're saying that a sub n is just 2 times n?
Oh, yeah.
Is that what you're saying?
Yeah.
Hey, great job, guys. Guess what we just found?
Nice.
We call that the explicit formula.
Oh, gosh.
Is it because of statements?
Well, the
It's
reason
because it has bad ones.
I'm not really sure why we call it explicit, but ultimately the nice thing about it is the explicit formula allows you to jump to any term.
So cheap.
You can think of it like that.